Chapter 3 review. Let's work out some of these odds. Oh, whoops, I guess I can't move that. Okay, let's work out number 5. Substitution. If you got a system of equations, one way to solve them is by substitution. Substitution is this: the idea that on top you have a y and on bottom you have a y, as well as your x's. X and x, and they're equal. Whatever y is on the top, that's what it's going to be on the bottom. Whenever x is on the top, that's what it's going to be on bottom. So our final destination, we want to figure out what is y, what value is y. Is y 5? Is it 10? And what is x? So if I know that y is 5, for example, that means that on the top it's 5 and on the bottom it's 5. In both places it's the same value. So if I know it's the same value, I'm going to use that idea to substitute. This bottom y, the one that's all by itself, is equal to a negative 7x plus 13. So if my top y and my bottom y are equal, I know that my top y is equal to my bottom y, which is also equal to a negative 7x plus 13. So I'm going to take this negative 7x plus 13 and I'm going to replace it with y. So here we go. That top equation is a negative 2x minus 3 times y, and that's all equal to a negative 20. Now I'm going to substitute in place of y something that is equal to it, which is this negative 7x plus 13. Alright, now I've got an equation just for one variable and I can solve it. So I'm going to first do the distributive property. I'm going to multiply both those terms by a negative 3. So I'm just going to bring this negative 2x down, and I'm going to have a negative 3 times a negative 7x, and that's a positive 21x. A negative 3 times 13, that's a negative 39, and that's all equal to a negative 20. So combine my like terms. Let me add up these x's right here. And I'm going to get 19x minus 39 is equal to a negative 20. So now I'm going to add 39, and I'm going to have 19x is equal to 19. Then I'm going to divide by 19, and I have my x. X is equal to 1. So I know x is 1. Now if I know that x is 1, I am going to take that x is 1 and I'm going to substitute it right here. So I'm going to have this equation: y equals a negative 7 times x, and I know x is 1, plus 13. So y is going to equal a negative 7 plus 13. Y equals 6. So I'm done. There is my work. Y is 6, x is 1. Alright, let's look at, let's do an elimination one. So I've got to go here. Let's look at 9. 9's going to be probably the hardest one. Alright, so if we go to 9, problem number 9. Now elimination is a little bit different. Elimination, what you're going to do is you're going to add them vertically. So they're all stacked up on top of each other, and I'm going to add them vertically, and I'm going to try to eliminate either my x's or my y's. And so I look at my x's. 4x minus 2x, that's going to be 2x. Negative 16y 8, that's a negative 8y. So I cannot move on because neither my x's nor my y is eliminated. So if they don't eliminate, you're going to have to force them to eliminate. You're going to have to get a little bit creative. And I'm going to try and force my x's to eliminate. Or actually, you know what, this might be, I kind of see something that'll be pretty slick. Well, let's go ahead. Let's just eliminate my x's. So if I look at my x's, 4x and a negative 2x, if I find the LCM of 4 and 2, I see that it's 4. So I can change my 2x's. If I times the whole bottom equation by 2 to to let me copy and paste this top equation. 4x minus 16y equals negative 16. The bottom equation, if I times everything by 2 times a negative 2x is going to be a negative 4x, and right there is my 0. 4x minus 4x, there's 0. Okay, but now I have to times every piece by 2. So 2 times the 8y is 16y, and 2 times the 10 is 20. So now look at this, my y's are going to cancel also. So 0 x's, 0 y's, and over here I've got 4. So this is kind of weird, it's unusual. We're in kind of weird area, weird territory. But let me look and see what's going on. I have this, 0 equals 4. And I know that 0 does not equal 4. So that is a false statement. And I know that this system must be parallel. So there is no solution. These lines are parallel, they're never going to cross. No solution. Okay, let's look at 13. 13, 10, 11, 12, 13, oh, 14. Alright, let's look at 13. 13, you got a system of inequalities. So I'm going to look at this top equation, and I need to find two things. I need to find the slope and the y-intercept. The y-intercept is always this right here. It's the constant. It's the number all by itself, which is negative 2. So my b is negative 2. My m is the number right in front of x multiplied to x, and in this case it's 1. And m is slope, m is rise over run. So I'm going to make it 1 over 1, and b is negative 2. So on the y-axis, b is negative 2 right here. And I'm going to go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. Down 1, left 1, down 1, left 1. Okay, now before I connect the dots, because it's an inequality, you got two options, dotted line or solid line. This is going to be a solid line because the inequality has the equal to, so that means it's inclusive. So your answers could be on the line. And now you're going to shade everything above it or everything below. So y, that's your answer. If I read this in English, it says my answer is anything less than this line. So this line right here, x minus 2, there it is. So my answer is anything below this line. On the y-axis, the more I go up, the bigger the numbers get. 2, 3, 4, 5, 6, 7. The further I go down, the smaller they get. So my answer is anything smaller. So I'm going to shade everything underneath it right here. Okay, now the second line, I still need to find m and I need to find b. The m right here is negative 3, and I'm going to put it over 1, then b is 2. So I'm going to start on the y-axis at 2, and I'm going to go down 3, over 1, down 3, over 1, up 3, left 1. This one is going to be a dotted line because it's just greater than, and my answer is anywhere above this dotted line. So it's up here. And so remember, the answer is the shaded region they have in common. So it's got to be above the blue line and below the red line. So the only area they got in common is right here. And that is my answer. Alright, last one. Maybe let's set up 15. And then we will call it good. Hopefully this helps. There's 15. Alright, 15. Oh shoot, that's kind of in the way. But it says the school that Anjali goes to is selling tickets to the annual dance competition. On the first day of tickets sales, the school sold 12 senior citizens and 12 student tickets, and they made a total of $204. The school took in $147 on the second day. They sold 11 senior citizen and 3 student tickets. So this part right here, what, some of it's cut off, but you hopefully you're looking one in your hand. This is your X and your Y. What is the price of each senior citizen and each student ticket? So I'm going to say X equals the cost of senior citizen, and Y equals the cost of my student. So the first day of sales and the second day of sales, I think those are going to give us our two equations. The first day of sales, let's see, how much money did they bring in? The first day of sales, they brought in $204. The second day of sales, they brought in a total of $147. So they got the 204 by adding all their seniors plus all their students, and that gave them 204. So to find out how much money they brought in from seniors, I don't know that, but I do know that they sold 12 tickets. So I'm going to do 12 times whatever the cost. X is the cost, so whatever the ticket cost, I times it by 12. Y is the student, and they sold 12 kids also. So whatever the cost of Y is, I'm going to times it by 12. And then the second day, let's see what we got on the second day. Second day, they sold 11 senior citizens. So that's going to be 11 times my X. Plus, I'm going to add to that whatever the cost of the student tickets. I don't know that, but I know they sold, let's see, how many did they sell? They sold 3. So, right there is my system of equations. And I am going to eliminate them. So if we add them up, let's look at my x's. 12 x's and 11 x's. The LCM of 11 and 12 is kind of a big number. I'm going to go to my y's. 12 and 3. The LCM of my y's is 12. I can change 3 into a 12. If I multiply this whole bottom equation by a negative 4, that will give me a negative 44x plus a negative 12y, and 147 times 4, what is that? That's 558, but I think it's got to be negative. And then I'm going to just bring down my bottom one. 12x plus 12y equals 204. Okay, and I'll turn you loose from here. You can wrap it up from here. So hopefully that helped.